Okay, hello everybody, I'm Dr. P. Patrick. So I'm going to discuss all the case of hypothesis testing one by one. Okay, so this video is talking about case 1 test for population mean when the sigma is known. Okay, so this is known already. So why it is known? So we go back to the questions. So in these cases, I would like to know the mean height of Hong Kong BU student. If you want to know the answer, that is almost impossible because Hong Kong BU is a university which contains many of the students. So if you would like to save time and to be effective, so you need to use hypothesis testing by collect 200 students. So these 200 students should be the sample size, and we need to find their mean, and find their mean is 1.68 meters. So this number is coming from the 200 students, and this is a sample mean. So this is a record down as x bar. If the distribution of the mean height, that means the population mean height is normally distributed with SD 0.1 meters. Well, this is a sigma because when you look back to the whole sentence, distribution of the mean height is normally distributed with the SD, standard deviation. Okay, the whole sentence means the population distribution of mean height is 0.1 meters for the standard deviation. So does this support that mean height of the whole BU student is less than 1.7 meters tall? So test has 5% significance level. So make sure that, first of all, we have to set the null hypothesis and the alternative. For the null hypothesis, we have to go back to the questions. If we talk about less than 1.7 meters, that is the solution that we are going to test whether it is true or false. But make sure that less than, we do not contain any equal meaning in here. So according to the previous video, as I said, how to set up the hypothesis is that for those without equal sign, we have to put on the right hand side. That means the alternative hypothesis. Mu smaller than 1.7 meters tall should be the alternative. Left hand side, of course, is the opposite for this symbol. So that means mu larger than or equals to 1.7 meters. And what's next is, since the sigma is given, okay, so if it is given, we have to use EZ test. So that means we have to check the EZ table, and the equation we are using should be the x bar minus mu divided by sigma over n square root. For the first numbers, x bar, it is coming from the question, so which is 1.68 meters, minus the number for mu. Remember that in hypothesis testing, all the number in this position should be the number you are going to test. So that means 1.7 meters. And then we divide it by sigma. Sigma should be 0.1, which is coming from the questions. And then we divide it by 200 for the sample size. And the last part is this number should be minus 2.828. So which is a test statistics. And in the next part is we are going to find the critical value again. Okay, so let me draw a graph in here. And then the next part is, so this is a EZ graphing. The next case is look at the alternative hypothesis. Smaller than sign, which means one tail test. So what it means by one tail test is if we go to test at 5% significance level, and then if it is a one tail test, so that means the 5% has to put on either left or right hand side. But is that we put on the left or right depends on the symbol on the alternative hypothesis. Okay, so this is a smaller than sign, and as I have taught already, the arrow point to the left hand side. So that is the easiest way for memorize. Okay, so 5% is on the left. And then for this 5%, we will reject the null hypothesis if the test value falling in a rejection region. For the large part, we will not reject the null hypothesis. And for the last part, this is a point which we will call the critical value. So why it is called critical value? Because this position, that is a number that we are going to check from the table, separate the reject null hypothesis and the region we do not reject the null hypothesis. And the last part is that we have to understand how to check this critical value. Okay, so go to the Z table. Left hand side for this point is 5%. So go to the Z table, and then we can see that the closer number to 0.05 should be somehow between these two numbers. For this number 0.0505, we have minus 1.64, and however for this number 0.05495, we look horizontal and vertical, so we have 1.65. If we take the average, that will be the critical value. So finally, minus 1.645 should be the critical value in here. And then if we go back to the test statistics, minus 2.828, that is the solution and the number which is on the left. So because this is a negative side, this is positive side, so of course minus 2.828 is somehow in the rejection region. So that's why in the conclusion we will reject the null hypothesis mu larger than or equals 1.7 meters at alpha, which is 5%. So make sure that you have to write down the significance level as well, because in different significance level, the critical value will be different, and then the conclusion will not be the same. So the conclusion is, if we reject the null hypothesis, so that means this statement is wrong. So therefore we will accept, and this conclusion, mu smaller than 1.7 meters, should be correct. So the conclusion is that the mean height of all the Hong Kong BU students is less than 1.7 meters tall. And that makes sense because from the sample of 200 students, you have 1.68 meters only. So in your conclusion, the mean height is less than 1.7 meters for all the Hong Kong BU students. So that is consistent. Okay, so that finished all the steps in the case 1.